Hello everyone. Our today's lecture for the AS level is naming compounds. Naming compounds in case of inorganic chemistry. The general rule for this is we mention all the substances, all the chemical compounds with the oxidation number of the central atom of the compound. Central atom of the compound. And these are the general rules whenever there is a bonding between oxygen and any other non-metal atom, then we use for all those compounds at the end ATE. For example, if we have a bonding between nitrogen and oxygen, we will call it as a nitrate always. Either it is written NO3 or either it is written NO2. We will mention the oxidation state of nitrogen in a compound, but the overall name will be considered as nitrate. Similarly, if the bonding is between sulfur and oxygen, it means that using ATE at the end, the name will become sulfate. Either it is SO4 or either it is SO3. Both of these will be called as sulfate, but the difference will be created using the oxidation number of the sulfur or central atom. Similarly, we know that phosphate, if the bonding between oxygen and phosphorus is there, either it is PO4 or either it is PO3 minus 3, that depends. We will use the oxidation state, but one exception is there for hydroxide from this rule. This rule is not applicable for the hydroxide, while all other substances, whenever the oxygen is formulating a bond with other non-metal atom, its name will end at 8. For example, this is our compound. Here, in this compound, we are looking that using the oxidation number rule, this is a normal compound of oxygen and the oxidation state in this compound will be -4 because one oxygen has -2 oxidation state. To balance this, as sodium has already 1, that's why the oxidation number of nitrogen will automatically becomes 3. So its name will become sodium nitrate 3. We will represent the oxidation number at the end of the atom using the Roman numerals. This is sodium nitrate 3 compound's name. This is, according to that formula, sodium chlorate 7. Why 7? Because the oxidation state of oxygen is here -8. Oxidation number of sodium is +1, that is fixed. Automatically, to make the algebraic sum 0, we will take +7 oxidation state for chlorine. So the name will become, using the oxidation number, as sodium chlorate 7. Sodium chlorate 7. And this is, if acids are present instead of a chemical compound, then we use the word IC at the end of their name. For example, this is nitrogen and oxygen bonding along with hydrogen showing acidic. This will be called as nitric. Nitric. How many oxidation state? Nitric 3 acid. Nitrate 3 acid means here the oxidation state of nitrogen is +3. But in this case, this is a nitric 5 acid. Why 5? Because here the oxidation state is positive 5, nitric 5 acid. What is the name of this? Potassium nitrate 3. Potassium nitrate 3. Why 3? Because the oxidation state of nitrogen is +3. Potassium nitrate 3. Name of this chemical compound. Similarly, this compound will be called as, if the oxidation state of oxygen is -2, automatically the fixed oxidation state of sodium is +1. To balance, definitely chlorine will have to adopt +1 oxidation state. So that's why the name of this substance will be called as sodium chlorate 1. Sodium chlorate 1. Name of this. Now, sodium nitrate 5. Sodium nitrate 5. Now, this compound can be mentioned as, if we look, oxidation state of oxygen is -2. To make the algebraic sum, we will take the oxidation number of copper +2. But this +2 oxidation state is of 2 copper atoms. So +2 will be divided by 2. Answer will become 1. That's why the name of this compound will be as a copper 1 oxide, because we have to find out the oxidation state of one atom. Normally, always, the oxidation state of only one atom is mentioned, copper 1 oxide. On the similar manner, sodium 6 sulfate or sodium sulfate 6. Sodium sulfate 6. Similarly, manganese 7 oxide. Manganese 7 oxide is indicating that the oxidation state of manganese is 7 in this compound. This compound. Phosphorus 3 chloride. Phosphorus 3 chloride. And this compound is indicating phosphorus 5 chloride. If we look at these names, if we want to write down their chemical formulas, sodium chlorate 1, it means that the chemical formula is this, sodium chlorate 1. Potassium nitrate 3 means potassium nitrate 3. This is the chemical formula for this name, systematic name. Similarly, phosphorus 3 chloride or phosphorus 5 chloride. Phosphorus 3 chloride, phosphorus 5 chloride. We have already discussed in this manner. All the compounds are named, but we mention the oxidation state of the central atom, and there, because we are not using now the sulfurous or sulfuric acid, the nitrous or nitric acid, nitrite or nitrate. These names were used in the previous days, but now the systematic naming are done for the many chemical compounds using the oxidation state of the central atom. Now next is balancing the equation using oxidation number. Next is balancing equations using oxidation numbers. How this work? We are going to explain. For example, consider that there are some equations present. For example, I am putting here one example. HBr reacts with H2SO4 and then it gives Br2 plus SO2 plus H2O. This is the equation, and we have to balance this using the oxidation number method. first of all, we have to write down the equation and then we have to mention their oxidation number on the all atoms. For example, in this compound, bromine has -1, hydrogen has +1. The algebraic sum will become automatically 0. Here, the oxygen has -8, hydrogen has +2. Automatically, to make algebraic sum 0, this will come +6. Mean sulfur has oxidation number of +6. Here, bromine has a 0 oxidation state because this is molecule 1. Sulfur dioxide. In case of sulfur dioxide, oxygen has -4 and sulfur has +4 oxidation number. In case of water, -2 and +2 oxidation states are there. Now we have in the second step we have to select those atoms whose oxidation state change. Now it is clearly indicating that bromine oxidation state is changed from -1 to 0. From -1 to 0. And secondly, the sulfur oxidation state is changed from +6 to +4. From +6 to +4. Now, first of all, we have to take into consideration the total number of atoms. And for example, here bromide ion is 1, but here in bromine molecule 2 bromine atoms are there. That's why we can use here the 2 to balance the bromine atom on the both sides of the equation. Now, if we consider 2 bromide ion, it means that 2 bromide ion lose 2 electrons. 2 electrons loss. They lost 2 electrons and make 1 bromine molecule. Make 1 bromine molecule. This is oxidation process. This is oxidation process. As the oxidation state is increasing, it means that oxidation of bromide ion is taking place. It means that this HBr as a whole is acting as a reducing agent. Now, what is happening here? The oxidation state of sulfur is changing from +6 to +4. It means that 2 electrons are gained. 2 electrons gain. Electron gain is called reduction. This is reduction. And as the reduction of sulfuric acid is taking place, that's why this is acting as oxidizing agent. Now, in the third step, we have to look either the electron lost or gained are equal or not. We have to make them equal. If these are not equal, then we will multiply with suitable digit to equalize them, and that digit will also be multiplied by all those atoms or compounds whose oxidation state is changing or which is mentioned by the data. Now, in this case, as the number of electrons gained or lost are equal, that's why no need to multiply with any suitable digits. So, in the next step, we will balance this equation by the hit and trial method. Now, we have already converted to HBr plus H2SO4. Now, it is going to convert into Br2 plus SO2 plus H2O. Now, for hit and trial method, we know that first of all we balance that atom which least comes in the equation. For example, sulfur is the least. One sulfur is there, one sulfur is there. On the reactant product equal. Second is bromine. 2 bromine here, 2 bromine here also become balanced. Now next come oxygen and hydrogen. How many total hydrogen are there? 2 hydrogen plus 2 hydrogen, 4 hydrogen. Here on the product side only 2 hydrogen are there. We will multiply this equation by 2 to make the hydrogen 4. Now what less or what next? The left element is oxygen 4. Automatically the oxygen become 4. 2 oxygen plus 2 oxygen 4. Now this equation is balanced out with the help of oxidation number method. Now oxidation number method helps us very much in balancing the equation. We can take another second example for balancing the equation. Second example for balancing the equation is, for example, if we have to balance V positive 3 plus I2 plus H2O. This will give us VO positive 2 plus I negative plus H positive plus H positive. Now, look at the equation. We have to find out, we have to write down the oxidation state first on each element. Now, oxidation state of vanadium is written automatically. The oxidation state of iodine is 0, and the oxidation state of hydrogen and oxygen here is positive 2 and minus 2. The oxidation state of this ion is written here. We have to find out the oxidation states of vanadium here. Using the oxidation number rules, we will find just like this: V, then plus, minus 2 is the oxidation state of oxygen. How many oxygen atoms are there? 1, and is equal to positive 2. Now, what will be the answer? Answer will become minus V plus multiplied by minus 2 is equal to positive 2. Now, V is equal to positive 4. It means that the oxidation state of vanadium here is positive 4, actual. And the oxidation state of iodine is minus 1. Now, we can clearly indicate using arrows which element is oxidized and which is reduced. Now, it is quite clear that this vanadium is changing from positive 3 to positive 4. Positive 4. While iodine is changing from 0 to minus 1. What is happening? If we balance the atom first, one vanadium is there. Okay. Now here the 2 iodine atoms or one iodine molecule is producing one iodide ion. If we balance a number of atoms first, then definitely we will multiply by 2 iodide ion. Now we have to check how many electrons are lost during this process. 1 electron is lost. 1 electron loss. Mean oxidation, mean reducing agent, acting as reducing agent. Here, each iodine atom gaining 1 electron. It means that 2 electrons gain. Mean reduction, mean oxidizing agent. Oxidizing agent. Now we have to balance electron gained or lost. The loss of electron is taken away for 1 electron and gain is of 2 electrons. We will multiply by this by 2. We will multiply by this by 2, and this digit will be multiplied by with both the species. Now this will becomes V positive 3 plus I2 plus H2O. Now 2VO positive 2 plus 2I negative plus H positive. Now we have to balance rest of the equation using the same formulas. First of all, that element is balanced, which is coming least. 2 vanadium, balanced. 2 iodine atom, balanced. Now, what left? The leftover is oxygen and hydrogen. Now, how many oxygen are there on the product side? 2 oxygen are there. Definitely, to balance the oxygen, we will multiply by what? By 2. And now, we have to balance the hydrogen. Hydrogen on the reactant side is 4. On the product side is 1. We will multiply by this by 4. Now, we have to balance the charges also. This equation is indicated 2 multiplied by positive 3. Its total oxidation state is coming positive 6 because iodine has 0 oxidation state and water has also 0 oxidation state. Altogether present. Now, what is the situation here? Here is positive 4, then minus 2, and then how much? Again positive 4. Positive 4. What will be the total answer of this? Answer of this will also become positive 6. It means that the total oxidation state on reactant side and on the product side, and the total charges on reactant side and product side, and the total number of atoms on reactant side and product side, all these are equal. This is indicating that the equation is balanced now in every aspect. And this is the method how we use the oxidation number to balance the chemical equations. I can go forward.